Okay, so the next topic what we are going to be understanding here is VPN concepts, which is more important to understand. When it comes to the configuration part, configuring VPN on checkpoint would be too easy to do it. So anyway, right? So we need to understand the underlying concept, like what is that VPN and how the communication is going to be established, and what is that and what do you mean by a tunnel, and what all the parameters are going to be negotiated. If parameters are not being negotiated successfully, what will happen? So those concepts are too important to do it. Max to max 5 minutes you can configure a VPN when it comes to, yeah. So but if something goes wrong, you need to be in a position to identify where the real problem is, so that you can easily troubleshoot it. So for that, these concepts are too important for you. If I ask you to define VPN, how do you define it? Fine. See, the purpose of going for VPN is what? You would like to provide connectivity between two different networks or two different people who are physically located in a geographically different location. So I have a network A, I also have a network B, and I would like to provide connectivity between these two so that people can talk to each other. The purpose of doing this one, of course, there are many solutions. You can go for a lease line solution as well. You can go for lease line. When I go for lease line, what is it happening? So I'm just trying to open up a dedicated circuit between network A to network B. This is what many people's understanding. Is that true? Actually speaking, it is not. Let's say that you are having a lease line connection, a dedicated circuit between your network and a service provider. Let's assume that you have a service provider here, right? So I have ISP, could be any kind of a service provider. When I say lease line, the connectivity between your network and the service provider is dedicated. This is how they are connected. It is not like a dedicated circuit between point A and point B. So the circuit what we are talking about is dedicated is from your point to the service provider point. The whole bandwidth is dedicated for you, but again it is going to be the traffic whatever you send through the lease line is going to be traveling through the cloud, but not a public cloud. The service provider cloud through which the traffic could be flowing through. So that's the reason normally even if you take a lease line connection, we try to secure the data flowing between network A and network B. Right? So the problem with lease line is very expensive. The sense, because you are going to reserve the bandwidth permanently for a certain period of time, whether you are going to be using that bandwidth or not, you have to pay for the service provider. That means if you are booking 1 MB of lease line link, whether you use the 1 MB bandwidth continuously throughout the year or not, you have to pay for it. So the advantage is the bandwidth is dedicated. The negative side is what? Even though you're not going to be using the bandwidth all the time, but still you have to pay for it because that bandwidth is reserved for you. No one will be able to use that bandwidth at all. Right? The second thing is for every circuit you need to reserve an interface on your side. That means what? If you have multiple sites that you would like to be connecting through the lease line, you have to purchase a dedicated link for each and every site that you are trying to connect it. So every circuit is going to be terminated, or every link is going to be terminated on its own dedicated interface. You cannot share that interface at all. So the lease line is costly. The bandwidth needs to be reserved for a period of time. Means if you're taking 1 MB link and then you have to put a agreement with the service provider that I would like to reserve it for 3 months, 6 months or 1 year. So you have to pay upfront, right? So that confirms that 1 MB bandwidth is always available for you whether you are using it or not. That's the reason they're taking the money in advance. And one more thing, if you would like to increase the bandwidth, that is possible, and the charges will be on a pro rata basis. That means after a month, you conclude that you would like to increase the bandwidth for 1 more MB. That means you have booked 1 MB bandwidth for 3 months, and after a month, you would like to increase the bandwidth to 2 MB. Yes, it is possible. So the remaining charges for 2 months will be collected for that additional 1 MB. Whereas if you would like to reduce the bandwidth, then that wouldn't be possible at all, because you have already paid. Assume that you have taken 2 MB of 2 MB link for a period of 3 months, and after a month you conclude that you need only 1 MB, not 2 MB, and you cannot go and ask for bandwidth reduction, and refunding wouldn't be possible at all. So this is one of the solution, but of course we also had something called as what your frame relay, ATM kind of a solution. They have their own advantages and disadvantages. But the point what we are trying to talk about, every company will be having an internet connection. People are connected to ISP, right? So internet service provider. So every network, every company or every individual will be connected to the service provider, the internet service provider. All of them will be having at least one dedicated IP address. And why don't we form a logical tunnel between these two IP addresses so that the data could be secured? So this is what we are trying to talk about as what? A private VPN tunnel. So VPN or virtual private networks are virtual in nature. In what sense? Once this tunnel got established, though they are physically in a geographically different location, they are logically sitting in the same location. Virtual private networks are virtual in nature. In what sense? Once the connectivity got established, both the parties are logically sitting in the same location. In that sense, it is virtual. Virtual private networks are private in nature. In what sense? Since the tunnel or the connectivity is going to be established over a public medium, that anyone can be connected to the public medium, they would be able to see what is that happening. That wouldn't be possible, because the data, whatever you exchange through that logical tunnel, is going to be private. So virtual private networks are private in nature. Over the public medium, whatever the data that you transmit, your data is going to be private. So virtual private networks are virtual in nature. In what sense? Once the connectivity got established, both the parties are virtually sitting in the same location. Virtual private networks are private in nature. In what sense? Over the public medium, your data is going to be private. Now, how this privacy or how this security is going to be addressed? When I say security, it needs to be addressing three different components, which are called as what? CIA. So it's a security triad. So any application that is addressing the CIA, then we call that application as a security application. Let's try to understand whether VPN is a security application or not. Of course, it is a security application. So in that case, it has to address confidentiality, integrity, and availability. Let's try to understand what is this. What is confidentiality? Okay, let me explain this one. I have system A, I also have system B, and assume that they are connected through a VPN tunnel. Okay. Now the data is going to be sent from system A. What the data is being sent is GOPI. If the data is GOPI, I'm not securing it. People whomever is sitting on internet, they will be able to see what data is being exchanged. Correct? So to address that one, I'm just going to be protecting this data. Right? So when the data is being transmitted over the public medium, so okay, now let me try to say how this confidentiality is being achieved. Encryption. What is encryption? No, we'll see later. But what I'm trying to say, I'm trying to send some data called as what GOPI that gets encrypted and then being forwarded via a link. People whomever is there, you're claiming that nobody can access it. There are different explanations or descriptions for that. Converting a ciphertext into an ununderstandable ciphertext is what? Encryption. And encryption is a reversible process. Okay. So what I'm trying to mean it as, if I have to send something called as A, I will not be sending data as A. That can be converted into something else. It could be like an exclamatory symbol or whatever it might be. So A is not being transmitted as A, but A is being converted into something else and then it is being transmitted. People whomever sees this exclamatory symbol, They can see it as an exclamatory symbol. Okay. So it doesn't mean that what we are exchanging is not readable by the third party. They could, but they wouldn't be getting the original data. So the context of the communication is not understandable for the people who are not authorized for it. Right? So encryption means what? Converting the data into an ununderstandable ciphertext. Most of the places it would have been written as unreadable. But actually speaking, it is ununderstandable. So so that confidentiality means what? The original context of the communication is understandable only for the transmitter and receiver. Rest of the people may see it, but they wouldn't be able to understand what is being exchanged. But still they could read it. Okay. Assume that you and me are sitting in a public. Okay, we have some 10 friends sitting together. And we have some a private language which you and me alone can understand. We are trying to communicate with each other in that friends group publicly. People can hear you, but they wouldn't be able to understand what is that we are communicating. They know that we are communicating, but they don't know the meaning of our communication. Do you understand what I'm saying? Yeah. So that is what confidentiality is all about. Maintaining the secrecy of the data. Right? So confidentiality means what? Whenever the data is being sent and received, that would be understandable only for the transmitter and receiver, not for anyone else. Rest of the people may read, but they couldn't understand what is that being exchanged. They could see all as some junk values. They could. Okay, so confidentiality is being addressed through what? Encryption. So encryption, I have already given you the, what is it called? A definition for that. Encryption is nothing but converting a clear text into an ununderstandable ciphertext, then sending it. Encryption is a reversible process. That means the transmitter will encrypt the data, receiver needs to decrypt the data. Right? So encryption is of two types. One is symmetric and asymmetric. What I'm trying to mean is symmetric and asymmetric. Okay. I told you that the data is going to be converted, the clear text is going to be converted into an ununderstandable ciphertext. That is going to be based upon a standard. If that is not a standard, even the sender and receiver wouldn't be able to secure the data. Assume that my standard is going to be like E1, whatever it could be. So my standard says that how the data is being converted into a ciphertext based on something called as E1. Similarly, B should also be knowing about E1. Only then he will be able to decrypt it. And that is going to be a standard. If that is not a standard, then the interoperability will be a problem. So these standards are very defined in some documentation, something like your RFCs, how this could be possible. And those documents would be available in public. My point here is, if people are using a standard method to encrypt the data, and that standard has been defined in a document, people can go and read the document and try to understand how E1 works. If they know the algorithm, obviously they could also decrypt this and get the clear text, correct? And how the protection is happening. Okay, so that is where a key comes into a picture. Algorithm is open standard, yes, but the key is going to be private between the sender and receiver. So when someone is trying to understand the encryption decryption algorithms, of course they could go and read and understand how this works. But until unless they could capture the key for that communication, they wouldn't be able to decrypt the data at all. So key is playing a very vital role in encryption. So based on the usage of the key, we differentiate the types of encryptions, symmetric and asymmetric. A sender and receiver, if they both use the same key for both the functionalities, for what? encryption as well as for decryption, then we call it a symmetric key cryptography. Right? So sender and receiver both will be using the same key for encryption as well as decryption. Assuming that whenever A is sending data to B, the algorithm is E1, the key is K1. Okay? The algorithm is E1, key is Q1, and which is known only between sender and receiver. So whenever data is being encrypted, the data is going to be protected or encrypted using the algorithm E1 and key K1. Though the algorithm is known to the general public, since they are not aware of this key, they wouldn't be able to get the original data. When the data reaches on the other end, system B, since he knows the algorithm as well as the key, he is going to reverse the process and then he is going to reverse the process with the key and then he will be getting the original text. So sender and receiver, both of them are using the same key for encryption and decryption. That's why we call it as symmetric key cryptography or symmetric encryption. Encryption and decryption. Popular algorithms are DES, 3DES, AES. Very popular algorithms. In what way they differ? DES, triple DES or AES? Assume that, let's say, this is my data, which I'm trying to send it to the other side. That is going to be sent through, okay, this is my data. This data is going to be sent through a process called as what? Encryption. When I do that one, a key is being used and the output is what? Hypertext. So, adding the key to the clear text based on the algorithm will derive you the ciphertext, right? So what the other side will be doing it, this ciphertext is being sent over the public medium. The receiver receives the data, means which is nothing but in his case, it is a ciphertext. What he has received is what? Ciphertext. What he has to do, he has to reverse the process, something like, he has to reverse the process we call it as decryption using the same key. What is it called? Key K1. Because of that, he will be able to get data. This is going to be on by both the directions. This will be happening. Whomever is going to be sending the data, he will be adding the key based on the algorithm so that he can encrypt the data and which will be forwarded over the public medium. When the receiver receives it, he has to reverse the process, reverse the algorithm with the same key so that he will be getting the original data. Okay, so this is typically called as a symmetric key cryptography or symmetric key encryption. But the point is, what is the strength of the key decides the strength of the encryption. Because I told you already, if the key can be compromised, no anyone can decrypt the data. Because algorithm is open standard. How secure the key is, or how strong your key is, that is being defined based on the key sizes. For this, the key size is what? Okay. Let me try to explain you what is that key size now for you. Let's say that I have a number lock suitcase. Okay? And this number lock suitcase has been locked using some keystrokes or key combination or number combinations. The point is how many columns you have, based on that the size of the key is going to be derived. Assume that I have 2 columns. That means in every column you can have the digits between 0 and 9. Right? So if I have 2 columns, then what will happen? 100 different keys could be set. That means of course you can set only one key, only one set of combination through which you will be able to open it up. Assume that this suitcase has been stolen. What he has to do to open the suitcase? He has to try out 100 different combination. Once he will be able to open it up. Right. What if I increase one more column? He has to try 1000 combinations. Increase one more column. So the strength of the key is being determined based on the key size as well. This is not only based on the key size, but of course key size is also playing a vital role in determining the key strength. So we normally say the size of desk is 56 bits. It means assume that you have 56 columns. But here in every column you can have only 0 or 1 because it's binary. Right? So 56-bit key will be applied on top of data to get encrypted. The algorithm is DES. DES says that you have to use a 56-bit key. Okay? So key is going to be 56-bit and the algorithm says how the data could be encrypted using the key. When it comes to triple DES, 3 times of DES, which equivalent to what? 3 into 56-bit. We call it as 168-bit. See, when it comes to 3 DES, assume that this is like how it's going to be working. I have clear text that is being sent through, what is it called? An encryption process using the key 1 to get what? Ciphertext. When it comes to DES, this is about 56-bit, correct? Yep. Okay. Now, what we are saying 3 DES, this is going to be repeated thrice. So I got a ciphertext that is again is going to be sent through the encryption process. Right? Let's say the same key. That's what DES is all about, right? Right. To get ciphertext 2. And this again encrypted to get a ciphertext. Again, the same key needs to be used in case of a symmetric encryption to get ciphertext 3. You understand? 3 times the encryption process is going to be repeated on data so that the data gets encrypted 3 times. This is almost like if you have a file that needs to be zipped. When you are zipping it, you put a password. That's the kind of a protection called as a DES. That zipped file can again be zipped. I have a file that gets zipped with a password. Again, second time that zip file can be zipped again. Second time also I am putting a password to get the zip2, and that zip2 is also going to be zipped again with a different password. Do you understand what I am saying? Yeah. Now, whether it is going to be a DES or a triple DES, if an attacker could capture this key, it doesn't matter how many times you are encrypting, the data could be easily decrypted. Then why do we have to go for triple dash? That is where different keys comes into picture. I'm not going to be using the same key for all 3 times. I could use 3 different keys. So the attacker needs to, so for example, let me put like this. First time encryption using key 1. Second time same encryption but I'm using a different key altogether. Third time I'm using key 3. So because of that, if an attacker needs to decrypt this data, though he knows the algorithm, he has to capture or he has to compromise all 3 keys, only then he will be able to get the original data. So is that not secure? Okay, so this is what we normally call it as triple dash. Right? But there are so many choices in triple dash. Let me say, we normally call this as 2, 3 triple E, 2 EDE or very popular. What I'm trying to say, key 1 encryption, key 2 encryption, key 3 encryption. That means 3 keys are being used all the time we are encrypting the data. That's what we call it as 3 triple E. 3 keys, encryption first time, encryption second time and encryption third time. That is what 3 triple E is all about. When I say 2 EDE, I will be using only 2 keys. Let me say like this. Okay. Here I have data, clear text. What I'm doing is encryption using key 1. Right? You will get ciphertext. You will get a ciphertext. Then again this data is going to be sent through this DES algorithm, but I will not be using encryption. This time I go for decryption with a different key altogether. So key number 2 is going to be used for decryption. Since the key is different, even if you reverse the process, you will not be getting the same text. Then, and the data is being sent through the DES process. This time we will be encrypting it using the key 1 again. Sorry. Since I'm using a different key for encryption, again it gets protected. I get ciphertext 3, ciphertext 2, and then the ciphertext 2 is going to be sent through an encryption algorithm. At this time we use K1 as a key and you will get ciphertext 3. Okay, in what way these two differ? In both the cases, 3 times the process is going to be executed, the DES algorithm. But the only difference is in case of 3 EEE, 3 keys will be used. In case of 2 EDE, only 2 keys will be used. When you have multiple tunnels and you are going for 3 triple E, then what will happen? You need to maintain those keys for every tunnel. If I have 10 tunnels, then how many keys I have to generate? 10 into 3, 300, 30 keys. 30 keys needs to be generated. In case of 2 EDE, only 20 keys needs to be generated. Of course, this is also similarly secure. So to store the key, you need more of buffer, and there is also a time comes when you have to regenerate the key. That time you have to generate only limited set of keys when it comes to 2ED, because every tunnel requires only 2 keys, not 3 keys. So this will be faster and it is not resource sensitive. What I'm trying to say, it is not going to be consuming a lot of resource compared to 3 AAA. Okay, so that is what we call it as 2 AAA. How do I know what is that my product supports? You shall go for these, what is that called, ICSA labs, and talk about the product. Select the product and then you can know about what is that is being supported by your product. It doesn't matter whether it is Checkpoint or Cisco or Palo Alto, whatever the product. All you have to do is select the product, select the vendor, and then select the product, and you will be knowing about it. What is the model it is being supported? What is the mode it is being supported? Even in DES and all, you have different modes altogether. 5 different modes are there. I'll tell you what is this. See, ECB, CBC, CFB, OFB, right? So different modes are there. So based on those modes, the protection is also going to be assured. It's not that all the modes will be supported by every product or every vendor. So you need to understand the criticality of the data is being secured. Let's say that. Okay, so DES is what? 56. Triple DES is what? 3 into 56, whereas AES is Advanced Encryption Standard. Comes in 3 different flavors: 128 bits, 192 bits, and 256 bits key sizes. So when you go for AES, you have the choice of giving a protection for the data using 128-bit key or 192-bit key or 256-bit key. However you want, you can start protecting it. Okay, now if a choice given, which one you will be using it? It is not that based on the number of keys or based on the size of the key, the protection is going to be applied. You need to know the lifetime of data that is being protected. So for all data, whatever needs to be protected, you will be applying the same level of security? Obviously no. You need to understand the lifetime and criticality of the data which is going to be protected using these encryption algorithms. Based on the requirement, you have to apply it. Assume that your data is valid for only 1 day, right? You can use any encryption algorithm. It is not that so simple to crack a key within a day. This has been said as broken, but how long they took? It wouldn't happen in 1 day. So you need to understand. So you do normally call it as what? Risk analysis, business impact analysis, right? So based on that, you will be understanding the criticality of the data, and then you will also need to know how long the data needs to be protected. Based on that, you have to take a call what algorithm and what key size we have to go for it. So it's not that all data can be protected using AES 256-bit. Okay, symmetric algorithm is what we have seen. Now let's get into asymmetric. What is that asymmetric? As the name suggests, I have two participating pairs. What is that called? A and B. So if at all they would like to communicate over a secure channel or VPN communication or whatever it might be, encrypted communication, they're going to be having a choice of what? Asymmetric encryption, they would like to go for it. Then what do they have to do is, they have to generate a pair of key. Let me call this as A1 and A2. Similarly, B will be generating 2 keys, B1 and B2. This is purely based on the algorithm. What do they choose? The point is, these 2 keys are mathematically related. Every participating pair needs to generate a pair of key, based on an algorithm. Those keys are mathematically related, but even though you know one key, you will not be able to get the other key. That wouldn't be possible at all. Though they are mathematically related, but still using one key, the other key cannot be calculated. Okay. Now the point is, sender have the option of encrypting the data using any of the key. You can use A1 or E2. It means the point is, data can be encrypted using any key. But the only condition is, it can be decrypted only using the other key, not the same key. Assume that A1 is being used for encryption. Then A2 needs to be used for decryption. That's the condition. That's what is possible. Right? If A2 is being used for encryption, then A1 needs to be used for decryption. Okay? The point is, how they can securely exchange the data is, both of them can share one key with each other. That means, assume that A is sharing A2. Similarly, B is going to be sharing his key. What is that called? B2. B has shared B2. Now A has, what are all the keys? A1, A2 and B2. Similarly, B has, what are all the keys? B1, B2 and A2. Now whenever the data is going to be sent from system A to system B, the data is going to be encrypted using the algorithm what they have negotiated. Now the key is going to be, key what I use is B2. Is that clear? Now the data gets encrypted using the receiver's key, not my key. Now it is being sent to B. Of course, anyone can receive this data. Can they decrypt it? If at all they have to decrypt, they need to know B1 because the data has been encrypted using B2. When B receives it, he can easily decrypt because the key required is B1. B has B1. When B would like to transmit data back to A, what he has to do it, he has to encrypt the data using A2. Because B has A2. The data gets encrypted using A's key. Now when the data is being received by A, all he has to do is what? He has to use A1. Of course, the rest of the people can receive this data, but they couldn't decrypt it because they need to know A1. Right? So in this way, the asymmetric algorithm assures that the data is being protected. Okay, so okay. In asymmetric, different keys will be used. Both are mathematically related. Can't derive one key from the other. Right? One is used for, if one is used for encryption, and the other has to be used for decryption. That's the point you need to be understanding when it comes to asymmetric. So they also categorized this. What is that? Out of two keys, one key can be shared in public with everyone or anyone. Because of that, that key is known as public key. One key has to be kept in private, and because of that, that key is called as what? A private key. So one key can be shared in public and that key has been named as public key. One key has to be kept in private and that key is called as what? Private key. So often asymmetric algorithm or asymmetric encryption is also known as public key cryptography. Whereas the symmetric encryption is known as secret key cryptography because the secret place or the secret key plays a very critical role. The popular asymmetric algorithms are Diffie-Hellman, RSA. Diffie-Hellman is an asymmetric algorithm. RSA is also a popular asymmetric algorithm. But if you see, expand this DH and RSA, Diffie-Hellman, Rivers, Shamir and Adleman, all of them are mathematicians. Of course, encryption is all about, what is it called? Mathematics only. Now, if you see the key size of asymmetric algorithm, a minimum key size is 512 bits. It can go larger as well. The minimum key size of what is it called? Asymmetric algorithm. And people may claim that, okay, why don't we go for asymmetric algorithm for data encryption because the key size is larger and of course it will be hard to crack it. Am I right? But are we using asymmetric basically for all the sort of encryptions? No. No. Okay. When we talk about this VPNs, we'll try to understand how this is going to be working. Okay. So that's what your confidentiality is all about. This is what we have seen. So confidentiality assures the data what is being exchanged between the parties is being secret and which can be understandable only between the sender and receiver. Though the rest of the people can see, but they wouldn't be able to understand what is being exchanged. That is where the confidentiality comes into picture. The next is what? Integrity. Now the point here is the data is going to be encrypted. The data is going to be encrypted using some algorithm and using some key. And then it is going to be transmitted over the public medium to the receiver. Okay, let's assume that A is what is going to be transmitted. I would like to send some data called as A. And because of the encryption, the output was what? B. When the receiver receives the data as B and when he decrypts it, he will get A, correct? So he receives B, that is going to be sent through the algorithm in a reverse process, what we call it as a decryption, to get A. So the whole world can see the data what is being exchanged as what? B. There's no confusion in that. Now the point is, the intention of the attacker is not to see what is being communicated. He would like to do some changes. What is that? When the data is being exchanged, when the data is being transmitted over this public medium, what he does is, he is trying to change it to something else. See. Now what will happen? The receiver receives the data, right? The receiver receives the data which is not B, which is C. If he is going to reverse the process, means decrypt it, do you think he will get A? So it would be something else. It could be something else, right? It could be anything but not A. So the output, or when the data is being decrypted, he could get something else as B. So A has been converted into B and then being transmitted while the data is being on the cloud, and anyone could modify it. In my case, I told you that it could be changed as C. When the receiver receives the data as C and it is being sent to the decryption process, he will get B but not A. Now the intention of the attacker is not to see what is that happening? He just want to confuse. He just want to modify the data so the sender and receiver, even though the data is being exchanged in a secured manner, they couldn't get original information. So how this can be avoided? So there must be a mechanism because the data is being exchanged on the public. When the receiver receives the data, he must be having a mechanism to cross-check whether the data has been modified on the wire or not. Now, how this is going to be achieved is when the data is being transmitted over the public medium. Of course, when the sender is sending the data, he will take a copy of it. Okay, so I would like to send some data. Before I do this one, I will be taking a copy and then copy of data is going to be sent through a process called as what? A hash process. Because the integrity is being achieved, hashing process. Right? Hashing is a one-way, non-reversible process. That means you can get hash value from data, but you cannot get data from hash. It is a non-reversible, whereas encryption is a reversible process. Data gets encrypted on one end, gets decrypted on the other end. Whereas when it comes to hash, you can get hash from data, but you cannot get data from hash. That is not possible at all. And also, hashing will give you a fixed length output. The size of the data or the size of the file on which you are generating the hash value doesn't matter. It could be 1 MB, it could be 1 GB, or it could be 1 KB, or it could be 1 byte. But the output of the hash value is going to be in a fixed length output. And the beauty of that output is, as long as the data is same on which the hash value is being generated, whether you generate the hash value or I generate the hash value doesn't matter, we both will get the same hash value, as long as the algorithm is same. So the hashing is a one-way, non-reversible process, will yield you a fixed length output. It doesn't matter who's generating the hash on the file. The hash value will be the same. So what a sender is doing, he is generating the hash value before sending the data to the receiver to get the hash value, right? And that hash will be appended as part of the data whatever is being transmitted. Now I'm sending this data, right? Now the receiver receives the data plus hash value, right? This is what he is receiving it. What he has to do is, he has to store this hash value, what has been received from the receiver, and he stores this as received hash value. So this received hash value has been computed by the sender. Now what do I do? I'm taking the copy of data and then sending it through the hash process of mine. Of course, both must be matching. So what I will get? What I will get is a hash value. What I'm doing, and what I'm calling this hash value as a generated hash. This hash value has been generated by me, whereas this hash value is received from the sender. What I said about the hash value, if the data is same, it doesn't matter who's calculating the hash value, how many times he is calculating the hash value, this hash value will be the same. See, if the data is same, when the sender has generated the hash value and the receiver has generated the hash value, both must be the same if the data is same. When the receiver receives and generated the hash value, after that he will be comparing the generated hash with the received hash. If both are same, that means the receiver can confirm that the data has not been modified at all. If the data has been modified on the wire, the data will not be the same and the generated hash and received hash wouldn't be matching. In that way, he can confirm that the data has been modified. So he will simply ignore the traffic. So integrity is used to verify the received data has been modified on the wire or not, which is done with the help of a hash process. Hashing is a one-way non-reversible process. If the data is same, whether you generate hash or I generate hash, both will be the same. Okay, so in this way, hashing process is being helping us to validate the received data's integrity, received data integrity. Hashing, the popular algorithms are MD5 and SHA. MD5 message digest type 5, SHA secure hashing algorithm. MD5 uses 128-bit output. So whenever you generate the hash value based on the MD5 value, MD5 algorithm, you will get a fixed length output of what? 128-bit. It doesn't matter the size of the data. It could be 1 MB, it could be 1 GB, it could be any size. So the output of the hash value will be what? 128-bit. In case of SHA, it will be 160-bit output. Now the third component, what we are talking about is A. In general, A stands for availability. When it comes to VPN, the A stands for authenticity. That means that availability is being addressed with the help of availability. Sorry, availability is being addressed with the help of authenticity. CIA, we normally call it as what? Confidentiality, integrity and availability. When it comes to VPN, confidentiality, integrity and authenticity. So that availability is being addressed through authenticity. Right? When it comes to authenticity in VPN, there are two types of authentication we used to be talking about. But of course, both meant for the same purpose. Assume that I have a public cloud. I have two parties connected. Right? A tunnel is going to be established between these two people. Let me take the green color. Okay. Now the point is, when it comes to authentication, there are two places this authentication could happen. One is during the tunnel. Can I accept the tunnel request from anyone? Okay, I'm receiving a tunnel request. I'm receiving a tunnel request from the internet. It is claiming that it is coming from B. The tunnel request is coming from B. How do I confirm that the tunnel request is coming from B? I need to validate him. See, I'm receiving a tunnel establishment request from B. So I'm receiving a request from the internet saying that I'm coming from B. I would like to open up a tunnel with you. How do I confirm the request is originally coming from B or not? That is where one set of authentication will come. What I normally call this as a source authentication. During tunnel request. Right? The second one is, once the tunnel has been established, right? Once the tunnel has been established, now we are going to be receiving the data through the tunnel. Actually, the tunnel is a logical one. We will be receiving the data only on this physical link. Correct? How do you confirm that the message is coming from that source? And this kind of authentication is going to be called as message authentication. So, source authentication during the tunnel, we are confirming that the tunnel establishment request is coming from the genuine source. Once the tunnel got established, we are going to receive the data through the tunnel, and we have to have a mechanism that the encrypted message is coming from that source or not. That's called as message authentication. The source authentication normally we do with PSK, means a pre-shared key or a digital certificate. When the tunnel establishment request is coming to me, I just going to ask him, what is the passcode? Or send me your digital certificate, let me check it out, whether it's really you or not. So pre-shared key or digital certificate will be used for source authentication. For message authentication, we use HMAC. You remember we were doing the hash process. I have data. When the sender is sending the data, he will take a copy and then send it through the hash process, and that will yield some hash value which gets appended. Then it is being sent on the wire. When the receiver receives the data, right? When the receiver receives the data, he is going to store the received hash value. He take out the hash value and then store it as received hash value. He will take a copy of the received data and then he will generate hash value, which we were calling it as what? Generated hash. Remember that? Generated hash. And then the generated hash and received hash is going to be compared. If both are same, that means the integrity has been verified. Now, in case of HMAC, after taking a copy, before sending it to the hash process, I will be using a key. I will be adding a key to the data. Right? So, the hash value what is being generated here is data plus the key. Is that correct? Is that correct? So when the receiver receives the data, if he is going to be simply generating the hash value on received data, he will not be getting the same hash. So he also needs to add the key. Right? So when the receiver receives the data, he must be knowing about the key which is being common between both the parties. So the receiver appends the key along with the data to generate the hash value, and the generated hash and received hash is matching. Not only the integrity is being confirmed, we are also confirming the message is coming from that source, because the key is the one which confirms that. If the key is different, then obviously the hash value wouldn't be matching. So when the hash is being generated, we will also be using the key for generating the hash value. In this way, we are confirming that the message is coming from the genuine source. So with the help of HMAC, we are confirming the message is coming from that tunnel source only. Okay, now two things are here. Without a hashing process, HMAC is not possible at all. If at all you are planning to use HMAC, you have to have a hash process. If not, it is not possible at all. Right? So HMAC helps us to identify the source of the encrypted message, or source of the message. It could be anything. It will be using the hash process. When the hash process is being initiated, a key is going to be appended to it. So this is what the logic you need to understand when it comes to VPN. So the next step what we will be discussing is your tunnel establishment process, that we will see on the next class.